Alright everybody, this is just a quick review of adding and subtracting radicals. We'll look at when we can and can't add them and then walk through an example. So sometimes to understand when we can do things, it helps to see instead when we cannot. So when we talk about adding radicals, there are really two things we're looking for. The first is that the index of the radicals we're trying to add or subtract is the same. So for example, if I was trying to add, let's say, the square root of 2 with the cube root of 2, in this situation we cannot add because one of these radicals is a square root and one of the radicals is a cube root. So we can't add when the index of the first radical and the second radical are not the same. Another case in which we cannot add has to deal with the number underneath the radical. So for example, if I had two square roots, at first glance you would think, okay, they're both square roots, we should be able to add them. But if I make the quantities under the square roots different, I'll just use numbers, let's say 2 and 3, then I cannot add in this instance because those numbers underneath the radical, even though they're the same type of radical, do not match. So in answering the question of when we can add or subtract radicals, I really approach that from when we can't. So let's go ahead and try an example. And if you look at this example, our goal is to simplify 4 times the square root of 32x minus 2 times the square root of 8x. You might just say you can't do anything because the values underneath these square roots are different. Notice they are both square roots, so it does meet that criteria of adding, but the values underneath the radicals don't appear to be the same. Then the question for us should then be, is it possible to simplify these radicals and then potentially the value underneath could be the same? So let's go ahead and take a look. The square root of 32 can be broken down. I'm going to go ahead and use prime factors just in case this visual method helps understand simplifying the radical, which was done in another video. So 32 is really 2 times 2 times 2 times 2 times 2. And then my next radical has an 8 under the radical. 8 breaks down to 2 times 2 times 2. And then there's a little x under that one as well. So what I'm doing right now is just working on simplifying the radicals. I'm not worrying about the addition or subtraction operation at this point. In my first radical, I notice I have a pair of 2s, so I can bring out a 2. And I have another pair of 2s, so I can bring out another 2. And that looks to be it. So that means within the radical I still have 2x. For my second radical, I have one pair of 2s, so I'll bring out 1, 2. Within the radical still remains 2x. I haven't talked a lot about the numbers that were out front of the radicals to begin with, but you can see I just dropped this 4 down out front for my first radical, and I just dropped the 2 down out front for my second radical. Now I'm going to clean up a bit. The first radical has in front 4 times 2 times 2. That sounds like 16. So I have 16 times the square root of 2x for my first piece. And then moving along to the next piece, we've got 2 times 2, or just 4 out front, of the square root of 2x. Now's the point at which I'm going to refer back to the points we discussed a bit ago. We want to make sure when we're adding or subtracting radicals that they're the same type of radical, like square roots, cube roots, and that the values underneath those matching types of radicals is the same. So looking at what we have here, we both of these are square roots, right? And the quantities underneath the square roots are matching. They're both 2x. So at this point, I'm truly looking at it from the perspective of saying I've got 16 somethings minus 4 of the same somethings. 16 minus 4 means I've got 12 of those things. Well, those things are square root of 2x. So in this case, the simplified form would be 12 times the square root of 2x, and that's all we can do. So I hope that helps. We got a little review of simplifying as well as adding, subtracting. Make sure to try some on your own.